Problem 65, valid number. So for this problem, there are many ways to solve it, but I think if we don't want to remember the solutions, I think the best way is the state machine. We can solve it by using um, yeah, regular expressions. So that is one method. Another way is that we're gonna use a lot of if tags. Maybe there's 100 if tags we don't know, and it's gonna make a lot of mistakes. And definitely it is not so easy to solve because we have to remember in which condition, yeah, a lot of conditions. Definitely it's gonna be too much difficult for us to understand. So for this problem, I'm gonna use a state machine to solve the problem. The state machine is that for example, this is a 0, so this is my current state. It is for this not 0, and then by some actions it can go to state 1. So for example, this is state 1. So yeah, for example, I have a digit. Let's say I have a digit. I'm gonna use a sign to represent state 1, and state 0 is just from the beginning for the string. Yeah. So my action is that what kind of string I'm gonna choose. So for example, if I choose this one, minus or plus, so it's gonna be a sign. So yeah, if I choose a plus or minus, so it's gonna be a sign. This is gonna be my first character. So for example, my first character is a plus. So from state 0, state is my starting state. So I'm gonna start from 0, and I have so many choices. So one of the choices that I can choose the action of sign. If the action is a sign, according to this action, I can go to the next state. So next state gonna be 1. So this means the sign state. So this means by using this means my previous action gonna be a sign. So according to this sign, I'm gonna go to the next state. Yeah. So this is gonna be a sign. So after this state 1, I can still go to the next state. So for example, if state 2 represent the digit. So if state 2 represent a digit, so after the plus sign, maybe I gonna have a number 2. Yeah. So this means after that, I'm gonna use the character 2. I'm going to go to the next state. So next state is going to be the number state. So yeah, this is just one of the cases, positive 2 or plus 2. So this is also invalid. Yeah, so this is my as state. So if I can go to this state, so definitely this is a valid number. So for example, if I cannot go to this state, maybe this is not a valid number. So this is just one of the solutions. So we're going to use this kind of state machine idea to solve the problem. For the string, first of all, I'm gonna strip a little bit. Otherwise, I need to prepare a lot of strings. Yeah. So now, for the number, so for example, plus 2. If before it there are gonna be many numbers, so what's gonna happen? Yeah. So for example, I have plus 2. This is a number, but before it there's empty spaces. What's gonna happen? Or after it, I just need to strip it. So this is my first step. I need to just strip it to avoid using so many states. Otherwise, I have to use an actual state which is empty. Yeah. So before the from the starting point, there's going to be an empty string, and at the end, after the number, there's going to be an empty string. So in order to avoid define so many states, I just strip the empty space. Now let me just define my state. So normally, for the state, I'm gonna prepare an array, and inside it's gonna be some, it's gonna be some dictionary. It's gonna be some hash tables or dictionaries because, for example, this is a 0 state, and this is a state 1. So I'm gonna define the state according to the index. So this is for this array. This is the index 0. This means it is the state 0. This means it is the state 1. Yeah, so basically it's going to be something like this. So let me just start. So let me comment and just define some state. So for state 0, yeah, so this means it's going to be the start state. Yeah, definitely there are going to be many cases for the start state. You see, it can be a sign, or it can be a number. Yeah, or it can be a dot. Yeah, even though we don't have the dot cases, but according to here, a dot followed by digits, that is also a valid number. Yeah, that is also valid. So the start state, we're gonna have three different kind of state from the state 0. It means from 0 we can go to three different kind of other states. So yeah, this is just the start state. So for state 1, I'm gonna define it as the psi state. So psi before dot. Yeah, because before and after dot there can be a sign. So let me just prepare a number to represent it. So for example, plus 1 2 dot 3 4 plus or minus E5. So definitely this is a valid number. So it is like 12.34 times. Let me think about it. Yeah, it's going to be not this one. It's going to be E with maybe plus 5. Maybe here I'm going to plus or minus. Yeah. So it is minus 12.34 times 10 to the power 5. So this is a valid representation of a valid number. It is a valid number. Yeah, as you can see, 3e plus 7. It means 3 times 10 to the power 7. This just means minus 12.34 times 10 to the power 5. So this is just a valid number. So we're going to use this kind of number to prepare all our states. Yeah. So for this one, so for example, for this sign, this is a negative sign. So before the dot, it can have a negative sign, or after the dot, it can have another sign. So we just use state 1 to represent the sign before the dot. So everything we're going to define it according to this dot. There's going to be a number before the dot or number after the dot. There's going to be sign before the dot or sign after the dot. Or it can have a E. E is another state. Yeah. And after this sign, it can still have a number. This is another state. Yeah. Let's just prepare. So 1 is for the sign before the dot. Let me use for this index, it's going to be 2. So this 2, I'm going to define it as digit. Digit is just a number. Yeah, so digit before the dot. Let's use the index 3 to represent a digit after a dot. Yeah, but there are going to be two cases of digit after dot. So it can have some cases, for example, this one, dot 34. This means 0.34. This is also valid. Another is 1 dot. This is also valid. As you can see from here, this is a 4 dot. This means 4.0. This means 1.0. This is just a float number. This is also valid. So there are going to be two cases of the digit after dot. So the digit after dot and no digit and before dot. Yeah, so this is the state 3, and the state 4 it's going to be the digit after dot and has digit before the dot. Yeah, otherwise, if we don't prepare two cases, it's going to make mistakes. So for example, if we only have a dot, definitely it's going to be false because there's no numbers. Yeah. So if we were to if we find a dot, after that it has to have a number if there's no digit before dot. But if there's a digit before dot, so after that it is okay. So that is why we're gonna prepare two sets of digit after dot. So this is one of the difficult parts. So it's gonna difficult after digit after dot and no state before the dot. And another one is digit after the dot and has digit before the dot. If it has digit before the dot, for example this one, definitely this is valid. But there's no digit, this is only one digit, definitely it's going to be a false. But if there's a number after this digit, this means it's going to be valid. This means it is a 0.4. Yeah, I think that's all the cases. And let's just continue to prepare the state. I think it's going to take a little bit time, but after understanding how we're gonna define the state, it's gonna be really easy for us to solve the problem. It's gonna be just something like a template. So for the state 5, so after that, so this is a sign, and this is a before digit before the dot, and this is a digit after the dot. So after that, we're gonna define this e. Yeah. And what about state 6? It's gonna be this is sign, right? Sign after digit, sign after dot. Yeah, sign after dot. And for the state 7, it's gonna be the digit after dot. So that will be all the state. So we're gonna start from state 0, and then this is our starting state. After this starting state, definitely we can go to some other state. Maybe we can go to state 2 or 4 or 7, definitely. Yeah, that's gonna be the final state. We just need to check what's gonna be the final state. If the final state is valid, definitely this number is valid. Otherwise, it is not. Yeah. So since we defined all the states, so now we're gonna prepare each of the states, because definitely according to this state, and we need to do some actions, and the actions is just the string s. According to each of the character is one of the actions. Yeah, we're gonna do the actions one by one. So each of the character inside of the string gonna be the actions. Now what are we gonna do? We're gonna just prepare some empty dictionaries, because now we just need to prepare some hash tables to transform the state. Maybe from state 0 we can go to state 1 or 2 or others. Yeah, let's just check if we can go to other states. So for state 0, as I said before, from the beginning it can have a sign, right? Yeah, because from the beginning we can have a negative sign. This is okay. So if we have this sign, this means we're gonna do an action. This action gonna be a negative sign, and for this action we can go to another state. This state is the sign before the dot, because definitely we don't have a dot, so it's gonna be on state 1. But from the beginning we can also have a digit, right? Because like something maybe we have a 4, so this is also a value number. So from the beginning, from state 0, we can go to the digit. Yeah, so this digit just means the digit before the dot. So this is a digit before the dot. It is a state 2, so it means it can go to state 2. And similarly, we still have another case. It's going to be a dot. Yeah, because from the beginning, in this case, it is a dot. Yeah. So if it is a dot from the starting point, we are doing this action for the dot. Yeah. So after that, it's gonna be a number. It's gonna be a digit. So after the dot, it's gonna be a digit. So this digit called digit after dot. But there are two cases: digit after dot. Another one, we need to check digit after dot. We need to check if there's a digit before the dot or not. Yeah, because definitely this is a digit after dot, but this is just from the beginning. If we have this digit, it means we only have this digit. This means before the digit, before this dot, there's no digit. So this means we're gonna choose state 3, because 3 is no digit before the dot. So it means we can go to state 3. Yeah, it might seem a little bit difficult, but I will make a drawing later. Maybe this is gonna be really easy for us to understand. Yeah. So now we're gonna prepare. So if it can go to state 1, so state 1, so if it is a sign, so if it is a sign like here, it can go to state 1. So what happens for state 1? Yeah, so after the sign, it's gonna be a so after the sign, it will go to state 1. And in state 1, after the sign, definitely it's gonna be a digit. It can be a digit, right? So if it is a it is a digit, so we're gonna call digit before the dot. Yeah, because currently we didn't meet the dot, because currently we just go from the sign directly. This is a sign, it is 1, and it go to the digit, so it's gonna be a digit before the dot. Yeah, because we find a sign, maybe yeah, maybe some other cases. This is a plus sign, and we find a digit. It's going to be like this case. So we find a sign from this sign. It can go to a digit. So it's going to be D with 2. Yeah, but after yeah, but there are some other cases, after the sign, it can still be a dot, in this case. Let me just copy and paste. Yeah, so this is why this problem is really difficult, because there are so many cases. Even we consider the state, it's going to be a lot of cases. That is why we're going to prepare the state machine to solve the problem. For this case, we have a sign. So after this sign, we can have a dot. Yeah, it can have a dot. So if we have a dot, it's gonna be yeah. If we have a dot, it's gonna be the digit after the dot. Yeah, so it's gonna be. But before it, there's still no number. Before the digit, there's still no digit. Before this dot, there's still no digit. So this means it's gonna still be the state 3. Yeah, so let's just check if there are some other cases. So we have a sign. So after the sign, it can be a digit. So after the sign, it can be a dot. Is there any other cases? So for example, after the sign, it can be E or not. Yeah, and I think there's no such cases. Yeah, there's no such cases. I don't think there's such cases. So I think it is okay. We don't have this cases. After the sign, it's gonna have a E or something. Yeah. So currently, let's just make it like this. So after the sign, we have a digit, and after the sign, we can have a dot. Yeah, but after the sign, definitely we cannot have anything else. I think that's the only cases. I don't think there are other cases. So after the sign, it can be a digit. Yeah, or after the sign, it can be a dot. Yeah, so let's just continue. And what happens for the digit? So after the digit before the dot, it can still be a digit, so it's going to be a state 2. Yeah, so this means before that there's no digit. This is a sign before the dot. For example, we have a sign before the dot, and then we have a digit. So after the digit, we can still have the digit. Yeah, currently we don't have the dot. So this means we might have the dot. So for example, +4 dot some number dot 8 or some number like that. Yeah, or -12 dot 34. It can be some number like that. Yeah, so this means from here we still have the possibility to have this dot. So after this dot, what happens for this dot? This dot definitely it is a spatial. It means the digit before the dot. Yeah, it means before it there's going to be some digit. Even we have a sign, and then we go to this digit, and from here we can go to the digit. It means before the dot there can be some digit. So for this dot, it's going to go to state 4. It means digit after dot, and still it has digit before the dot. Yeah. Now, what happens for us is that we can go to the state 3. So the state 3. Let me think about it. So this is it's going to be the digit after the dot. Yeah, let's just check here. So we have a sign, and then we have a digit. Sign is 1. Digit is from here we can go to state 3, and after that digit, what's gonna happen is that we might have number. So after this digit, definitely we're gonna have number. So it's gonna be a D, and from here we can go to state 4. Yeah. So similarly for state 4. We can go to the state 4 itself, because after that dot it can be 2 numbers or it can be several numbers. So yeah, so from here we have it has digit before the dot. Yeah, we can go to the state 4. Yeah, let's I think there are going to be some edge cases we didn't consider, but I think I can still continue to check if there are some other cases. So this is a digit after the dot, and it has digit before it. Yeah, so is there some other cases? Yeah, so what happens is for this digit, it can still have some other cases. Yeah, because for this state, we must transform to other state. So this is a digit, and then it can have another digit, and definitely after that, it can be, it can be E. Yeah, so after the digit and after some numbers, it can have a E. Yeah, so we're gonna prepare on this case. So if we have a character E, it's gonna go to state 5, because state 5 is for the character E. Yeah, now we're gonna go to the state 5. So after the E, what's gonna happen for us is we can have a digit. So for example, after this E, we can have a digit, or we can have a sign. So let's just prepare a sign first. So so after this E, if we have a sign, so after this sign, it can be it can go to sign after dot. So it's gonna be 6. Yeah, so for example, if we have a sign and it go to 6, or we can have a digit. If we have a digit, it means we don't have this sign. Yeah, we can directly go to the digit after dot. Now, if we go to the sign, it can be a digit. So this is a state 6. This is a sign after dot. So if we have a sign after dot, after that it must be the digit. And finally, if we still have the digit, so for example from here we still have the digit, maybe we have so many digits, this is also okay. Yeah, I think this is the basic idea of how to solve the problem. There may be some cases I forgot, but let's just check later maybe. Yeah, let me just make the alignment a little bit. And let me just check the state again, because maybe something is missing. Yeah, because it's really difficult to think about all the cases. Sometimes you might forget about some cases. Yeah, so definitely from the beginning we can have a sign like this one, or from the beginning we can have a digit like this one, 4, or we can have a dot like this one, we have a dot. And then we're gonna start from the beginning. If it is a sign, it means we can go to the state 1, and for this sign we can have some digit. Yeah, And after this digit, we can go to the state 2. We can still, with some digit, for example, minus 12, we can still have some digit. And then, for this, after this digit, we might have a dot. So this means y from here, we're going to have a dot. Maybe for this negative 12, we have a e and plus 10, maybe something like that. Yeah, so this means here is something missing. I needed to prepare e, maybe without a character e. So for this e, we can go to state 5. So this state e. Yeah, so here I found something missing. Now let me just continue. Yeah, so after this e, I have the digit. So for this digit, I can go to here, and after the digit, I can have the e. So for here, after e, I can go to a sign. I think this is also valid with e10. Yeah. So this is why we have a digit. We can have a sign, or we can have a digit directly. If we have a sign, yeah, if we have the sign, we're gonna go to the sign after dot. So for this sign, we're gonna go to the state sign after dot, and it will be a digit, and it will go to state 7. Yeah. Now let me just prepare the final code. So I'm gonna prepare x. It's gonna be starting from state 0. Now I'm gonna check each of the characters. So for C, inside S, and I just need to check if C is a digit. So this means if C is a digit, so I'm gonna assign a character T. It's gonna be equal to the digit D. So D is for digit. So if C is a sign, so this means C in plus and minus. So this means T gonna equal to the sign. If C in E and capital E, because we have two cases. Yeah, you can see from here we have two cases, capital E and lowercase e. And in this case, T gonna equal to E. So another case is C equal to a dot. If C equal to dot, so T gonna equal to the dot. So else, this is gonna be the last case. We're gonna just assign this T. This means C can be anything else. And T gonna assign to a hash. I'm gonna use a hash. Yeah. Now I just want to check if we can go to the final state or not. Yeah. So here for this character in this side, and from here we just prepare assign variable T to a different state. So if not T in state X, so this means from the beginning it is not possible, or from other places it is not possible. We find some other characters, maybe ABC or something. So for example, maybe we find ABC or something, definitely we're gonna return false. Otherwise, we're gonna transform the state from this state to the next state. So this state X is gonna equal to state with X and with the X T. I'm gonna define the X as T. So finally, we just need to check the final state. X should be inside. So which state is valid? So for state 2, this is valid. If we can go to state 2, definitely this is valid. So for example, we have a number 4, and from this number 4 we can go to state 2, and we only have one number. It is valid. Yeah. So what about yeah, if we can finally we can go to state 2. It is valid. or maybe we can have a dot. So for example, from the beginning we have a digit. For example, it is 4, and then from here, maybe from the beginning we have a dot. So for example, but we didn't go to the state 2. Yeah, but the state 2 is valid, and this state 4 is also valid. Yeah, so for this case, it's going to be something like psi.9. So this is valid. We can go to this state. Yeah, so it's going to be 2, 4, and 7. So the final digit is going to be valid. So the digit after dot. So if there's a digit after dot, it's going to be valid. So it's going to be something, this kind of a digit after dot, and this digit after dot, it is valid. Yeah, so there are only three valid cases. Yeah, maybe you think, why not 1? 1 is not valid. So for example, we have a sign plus. From this sign, we're going to go to state 1, right? But this plus sign is not valid. We must have a number. Maybe you think state 3 is going to be valid. No, state 3 is not valid. Maybe we have a dot. So after the dot, we're going to go to state 3. Yeah, and we only have this dot. So this dot is not valid. So this is why we only have 3 states which is valid. I'm not sure if I can pass, but let's just try to submit to check if at least I can pass for some testing cases. If I didn't, I'm gonna try to check why not working. So let me just submit it to check. Yeah, as you can see, it works, and I passed for all testing cases. The only difficult part is about there are so many states, and we have to prepare so many examples. If we didn't prepare the correct state for transformation according to different actions, definitely we're going to make something wrong. Yeah. So the idea is that currently, let me make the drawing here. Currently we have a state 0. So from the zeros, we can do some actions. Yeah, we can do this sign. It can be a plus or minus action. If we do this action, we can go to state 1. This is one of the possible cases. And from this 0, we can also do the D. This D is going to be a digit. If we do the action D, it's going to go to state 2. And if we do the dot, this is also a valid action. We can go to state 3. And we can continue to make the drawing, because after we make the drawing, maybe it's really easy for us to understand. And after this is state 1, we can go to state 2. This is a what action? This is a action D. Yeah, we can go to state 2. And after this state 1, we can go to state 3. We're gonna do the action with dot. We can go to state 3. So the state 3 is gonna be here. Yeah, it's gonna be a little bit complicated, you know, while we are making the drawing. It always depends on how we're gonna make the drawing. Definitely we're gonna start from 0 and we're gonna go to our final state. Yeah, so there's gonna be some final state. So the 2, 4, 7 gonna be the final state. That is why we're gonna return something inside 2, 4, 7. Yeah, I think I've already simplified the problem because I've already stripped the empty space, and I prepared a less state. Otherwise, it's going to be much more difficult. And for here, basically, this is much easier to code. And the only difficult part is how we're going to define such kind of state. Yeah, you're going to have different kind of definitions for the state, but basically, it's going to be something like this. I think that's all about it. Thanks for watching. See you next time.